This is a disposable vape, and this is a tiny FPV drone propelled by this vape's power source. But how is it even possible? And how well does a vape's battery work on a drone? I decided to do an experiment and the results really surprised me. Stick around to find out. So as you probably know, vapes are thrown away everywhere. What you might not know is that inside them there is a rechargeable lithium-ion cell, the same kind as the one that powers your phone or laptop. And yes, it's always rechargeable, even if the vape itself is single-use. The difference is that here, the manufacturer does not include a charging circuit, meaning that a battery that can be charged and discharged hundreds of times is charged only once, and intended for just a single use before being thrown away. This not only wastes huge amounts of lithium, which is a limited resource, but also creates an environmental hazard because people throw these out everywhere. So, what can be done with vapes found in the wild? Well, aside from proper disposal, it's also possible to repurpose the cell inside to power things. I saw some people on YouTube extracting these cells from disposable vapes and using them to power electronics projects, and even in e-bike. But I really like drones, and I thought to myself, can such a cell power a tiny drone like this? Let's find out. So to start off, I need to open up the vape. Inside there is a plastic cylinder with a sponge soaked in vaping liquid. I am using gloves here since this liquid is something you should avoid touching. The cylinder housing the liquid and the heater can be detached from the electronics part. I am going to dispose of it. Underneath this plastic we have a circuit board with a lithium-ion cell attached to it. Before I proceed, I am going to wipe any liquid left with a paper towel. It's time to unsolder the battery while being very careful not to short it. These batteries have no protection circuits, so they require special care. Please don't try to replicate these steps at home unless you know what you're doing. The voltage across this cell is 1.9 volts, so it's quite discharged but not fully dead. So I soldered up a BT 2.0 connector to this cell, and I'm going to try it with this drone. It's a tiny whoop, and usually these are powered by high discharge lithium polymer cells like this one. So I am a bit skeptical whether this battery can power it, because I think this is a lithium ion, not lithium polymer, and I mean, this is specifically designed for a high discharge rate on a little drone like this, since these are not very efficient. I don't know, I mean, this was never designed for such a high discharge, so I don't know how it will go. Now I'm going to tell you some weight numbers. So the drone itself weighs 22 grams. The battery I typically use is about 8 grams. And this one is quite similar, also about 8 grams. And actually this one is rated for 300 milliamp hours capacity, and this one is rated for 360. So, but I mean, this was lying on the ground for some time, so I'm not expecting this to have its full rated capacity, especially since we'll be drawing such a large current with this drone. So, I mean, we'll see what we can get, we'll see if it even takes off. And to charge the battery, I'm going to use this LiPo charger. This one actually has a selectable voltage, so it's 4.2 or 4.35 volts. I'm assuming this can only go up to 4.2, so that's what I select. And it can also select between charging current of 0.2 amps or 0.6 amps. This has a rated capacity of 360 milliamp hours, so we shouldn't charge it more than 360 milliamps. So I set it to 0.2 amps, and I can just connect it using this. So now it's time to extract some more vape cells, using a similar procedure. It turns out that 2 of the vapes I found are actually reusable, at least they seem to be, since they have a USB port and a charging circuit. I don't know why anyone would throw them away, but here we are. Now, all that is left is to charge the cells and take them for a test flight. So I have these three cells taken out of a vape. This is the capacitor style 360 milliamp hour one. This is the bigger cylindrical 500 milliamp hour cell, and this is the smaller pouch style 280 milliamp hours. So we'll put them on this drone and see how they compare. So I put the first cell, the capacitor style one, on the drone and we'll give it a test. Well, I can see the voltage dropping to 3.6 volts straight away. But I mean, it's flying alright. I'll try to do a throttle pump. Oh, actually,
I've lost it.
it can, like if I do a throttle punch when it's fully charged, then the voltage drops very strongly, but like it still flies. Let's try some acro. I mean, it's flying alright, it's not very powerful, but it's doing much better than I expected for a vape cell. To be honest, I didn't expect a vape cell to be able to power a drone. Okay, so it's been flying for 2 minutes. Oh, but it's losing power. Oh! Okay. Okay, so 2 minutes is the maximum flight time. So it seems like 2 minutes is the maximum flight time I can get out of this capacitor style cylindrical cell. And let's check what's the voltage reading after the flight. It's 3.8 volts, so it's pretty good. So now I mounted the pouch style 280 milliamp hour cell and we'll see how it compares. Let's try some macro. I mean, here the voltage is also dropping to 3.6 volts straight away, 3.5. Let's try to do a flip. I mean, it can recover from a flip pretty well. But the voltage is dropping quite quickly. .1 volts. Let's see if we can get a bit more flight time out of this. Okay, 2 minutes. So we've passed the record with the capacitor style cell. This one was doing definitely better. Still flying alright. All I can feel it losing power. It needs more throttle now. Okay, 3 minutes. Probably time to run this now. With the pouch cell, I actually didn't run it down fully because I'm getting about 3 minutes with the standard cells that I use, so I didn't want to over discharge it and damage it. So if I measure the voltage with my meter, it says 3.84 volts, so it's actually, let's see that again. Yeah, 3.84, so it's actually doing quite well. The voltage dropped to 2.9 volts while it was still drawing current, but without the drone connected it's 3.84 volts, so it's actually doing very well, I would say. Oh, but I have to say it did get quite warm. It's not very hot, but it is a bit warm. So now let's do the final test. I've mounted the biggest vape cell I have, which is 500 milliamp hours, and let's see how it compares to the previous two. Oh, I can straight away see that the voltage is 3.7 volts now, so it doesn't drop quite as much. Oh, actually 2.6. I mean, it definitely has less power than on a standard cell, but that's true for all of these vape cells. Well, the voltage is dropping quite a lot, but I am not sure, maybe it's a bit better. I mean, the drone is definitely the heaviest with this one, because this cell is the biggest one. And it's 3.4 volts when I don't push it too hard, so it seems to be doing okay. Okay, so we are at 3 minutes and it's still an okay voltage. I mean, the voltage here seems low, but actually this is the voltage when the battery is under load, so the actual chemical voltage is higher than this. And this cell seems to be doing much better than the previous two. We are at 3.5 minutes of flight time and it's still reading 3.3 volts, so okay, so we are at 4 minutes 10 seconds and I'm going to land it now. Yeah, so the flight time here was definitely the longest. Again, I didn't run it down fully until the drone wouldn't stay in the air because I just don't want to damage these cells. But I mean, I've never been able to fly this drone for like 4 minutes 20 seconds on the standard cells, so the higher capacity here helps, but I can also feel that it's a bit warm, so it is definitely working hard. I mean, definitely with such a heavier cell the drone is a bit less maneuverable, but if you care about flight time, then yes, a tiny whoop can fly on a vape cell and it can actually fly relatively long. So it's 3.82 volts, so it's actually fine. I guess I could maybe push it a bit harder, just like with the previous one, but I was afraid of over discharging it, and I mean, a flight time of 4 minutes 20 seconds is still pretty good for a little 65mm tiny whoop like this one. So I'm pretty happy with the results. I never expected cells taken out of disposable vapes to be able to power a drone and to also be able to power a brushless tiny whoop, which is quite power hungry. So I mean, even under these high loads, these cells can perform relatively well, I would say. But I mean, this is not the only use case for these. You can also use them to power electronics projects, and actually powering a tiny drone is one of the most demanding things you can do with such a cell. So they could probably perform even better when they are not run at such a high load. So I really hope you enjoyed the video and maybe even learned something useful. This experiment has really inspired me to find more creative uses for the vapes I find. However, this doesn't change the fact that I would prefer to live in a world where we don't have battery-containing chemical hazard e-waste littered everywhere. Fortunately, some countries are taking steps to address this, such as Belgium and the UK, which banned the sale of disposable vapes this year. However, this might not be enough. I expected this video to be about disposable vapes. I expected to put the blame on manufacturers who design vapes that cannot be recharged. However, 2 of the vapes I disassembled seemed to be reusable ones, which someone decided to throw away in a public space. This is something I completely do not understand. Anyway, please let me know what you think in the comments. Thank you for watching.